I'm just going to talk through this paper, not really teaching the topics, but just going over the way I'd think of it if I was in the exam. So, looking at question 1, here's a function f of x equals 2x squared plus 7 for all values of x. What is the value of f of minus 1? I just sub in minus 1, so that's 2 lots of minus 1 squared plus 7. That's 2 plus 7 is 9. What is the range of f of x? This is asking what possible y values can this take, or can the function take. If we think of this function, it's going to look like a curve, 2x squared, and it's only going to come as low as 7. The lowest value is when x is 0, and that's going to be at 7. So the answer here is y is greater than or equal to 7. In fact, I should put that as f of x is greater than or equal to 7. That's the range of the function. Next question, multiplying the matrix A to the matrix B. So this is just a test of, am I able to multiply matrices together? And this is where we multiply the first thing in the row by the top thing in the column, so that's 2 times 5 plus the second thing in the row by the bottom thing in the column, plus 0 times 4. And on the bottom row we have 1 times 5 plus 3 times 4. So that's 10 plus 0 and 5 plus 12. So that's 10, 17, and that's my answer there. The greatest integer, work out the greatest integer value of x that satisfies the inequality 3x plus 10 is less than 1. This is solving an inequality and then giving the largest answer. So 3x plus 10 is less than 1, minus 10 from both sides. That gives us 3x is less than minus 9. Divide by 3, x is less than minus 3. So the largest integer value is minus 4. It can't be minus 3, it's not equal to, it's just less than. So x is minus 4 is the greatest integer value. Just putting minus 4 would get me the mark. Factorizing fully. If I was solving this, if it was equal to 0, I would divide everything by 2. And I'm going to look at this the same way, but just remembering that I can't divide by 2 because I've just been asked to factorize it. So I'm not allowed to change the value of this expression. So I'm going to effectively divide by 2 by factorizing and taking the 2 out of the front of the brackets. So I now have an easier quadratic to solve here, so that becomes 2, and I'm going to have double brackets here, x and x, and I'm looking for things that multiply to 20 and minus 20 and add to minus 1, so that's minus 5 and plus 4, and that's my answer, fully factorized. If you didn't divide by 2 first, or factorize the 2 first, you could put those into 2 brackets, but it's not fully factorized until you take the 2 out of the front, so you have to do that at some point anyway. This next one's more complicated looking because it looks like you have to expand the brackets first, but in fact x plus y is a factor of both of these parts of the expression, so both of these terms. So if I take the x plus y out of the front, or write it out in full perhaps first of all, this is x plus y plus x plus y 2x plus 5y. So x plus y is a factor of both of these terms, so I can take it at the front, and I'll open double brackets for the moment. X plus y times x plus y plus 2x plus 5y. But this I can simplify inside, so x plus y by collecting like terms, so x plus 2x is 3x, y plus 5y is 6y. And that second bracket, I can obviously, both of them are multiples of 3, so I can take the 3 out of the front of the whole expression, and that will be x plus 2y. So that's fully factorized. 3x plus y, x plus 2y. Simplify this expression. I'm basically just going to cube everything in the expression. So 2 cubed is 8, c cubed is c cubed, d to the power of 4 cubed, power law, so 4 times 3 is 12, d to the power of 12. You could also write this out as this expression times by itself 3 times. And then it might be easier to visualize how this is going to go together, but 2 times 2 times 2 is 8, c times c times c, c cubed, d to the 4 times d to the 4 times d to the 4 is d12. Solving these simultaneous equations, I want the same number of x's and the same number of y's, so I'm going to multiply everything in this one by 3. Let's go for the same number of y's. That gives me 6y equals 9x plus 12. And in this one, to get the same number of y's, I need to multiply by 2. So that's 4x equals minus 6y minus 14. But obviously these x's and y's are in the wrong place if we're comparing both expressions. So I need to rearrange this. I'll add 6y to both sides. So that becomes 6y plus 4x equals minus 14. And then I want the x's in the same place as in this equation as well, so 6y equals minus 4x minus 14. So this is my equation 1, and this is my equation 2. I'll write them out above each other here. 6y equals 9x plus 12. 6y equals minus 4x minus 14. Need to eliminate, so I'm going to subtract there. That's 0 equals 9 minus minus 4, that's the same as 9 plus 4, so that's 13x. 12 minus minus 14, it's 12 plus 14 is 26. Put that on the other side, so minus 26 equals 13x. Divide by 13, x equals minus 2. If x equals minus 2, then I'm going to sub that into this equation here. So 2y equals 3 lots of minus 2 plus 4 equals minus 6 plus 4 equals minus 2. Y equals minus 1. Check that that works in this equation. 2 lots of minus 2 equals minus 3 lots of minus 1 minus 7. So that's minus 4 equals 3 minus 7. That's true, equals minus 4. So it works for both equations and therefore it's correct. So x equals minus 2, y equals minus 1 is my solution to that problem. Right. Equation, circle theorems. This is a bit more complicated. Diagram shows a cyclic quadrilateral ABCD. This is ABCD. It's cyclic quadrilateral because all corners are on the circumference of a circle, which means that opposite corners will add to 180 degrees. That's the first circle theorem I think of when I see this. ADE is the straight line. CE is a tangent to the circle. That's the only tangent we've got. Work out the size of angle x. It doesn't ask me to give any reasons, so I just need to show my working to make sure I get all the marks for this. Now, firstly, when I look at this, there are loads of ways of approaching this. Either you just start writing in the angles that you know, or a more tactical approach is to say, well, here's a triangle. I know that this is a tangent, but I don't know anything about that line really. It connects to a chord and it's a straight line there. So what I can see are two triangles in here, or there. So if I can find some other angles within those triangles, both other angles, then I'll be able to work out what x is. First thing I notice about this is this angle within a segment, because both points are from a chord, that's going to be equal to this angle here. That's 46 degrees up here. And I don't have to give reasons, but in this I can just start labeling angles on here, and you get marks for labeling angles if they're correct in the diagram. That would give me the one angle of this large triangle AEC. I would then have to work out this bit here, and that bit there is angle between a tangent and a chord. And I know that the angle between a tangent and a chord is the same as the angle in the alternate segment. So this is one segment, this is the other segment, and because they're both off this chord, tells me that that angle is equal to this angle here. So that's 37 plus 46. Equals 83. So 83 degrees is in here, and x is going to be 180 minus both of those. So 83 plus another 46, that's 9, 12. So 180 minus 129, 51 degrees. And that's angle x. And of course I want to check that that adds up again, so I do 51, 46, 83, and check that it adds to 180. And it does. So that's fine. I've got that angle correct, and as I said, no need to give the reasons for that one because it doesn't ask for them. So things are getting complicated at this point. Beginning to get into differentiation now. So a curve has the equation y equals x cubed plus 5x squared plus 1. When x equals minus 1, show that the value of dy by dx is minus 7. So show that. First of all, I'm going to need to work out dy by dx, so this is differentiating that expression there. Dy by dx equals, bring that number down to the front, 3x, and reduce the power by 1, 3x squared, plus, it's going to be 2 times 5 when I bring that in front, 10x, and again reduce the power by 1, so that's 2x to the 1, or just 10x, and then this bit just goes because it's got no x values involved, so that just disappears. So 3x squared plus 10x, and now it's asking us to show that when x equals minus 1 that this equals minus 7. So I'm going to use x equals minus 1, that's 3 lots of minus 1 squared plus 10 lots of minus 1. That's 3 times 1 minus 10. 3 minus 10 equals minus 7, and so I've shown it is minus 7 there. Work out the equation of the tangent to the curve y equals x cubed plus 5x squared plus 1 at the point where x equals minus 1. We've done a lot of the work for this already. The equation of the tangent to the curve, that is has the gradient given by dy by dx. So it has a gradient of what we're given by dy by dx, a gradient of minus 7. So that gives me y equals minus 7x plus c. I have a point on this curve, but I need to know the y value of it. So x equals minus 1, but I also need to know what y is when x equals minus 1. So when x equals minus 1, y equals, from the original equation, minus 1 cubed plus 5 lots of minus 1 squared plus 1. That equals minus 1 plus 5 plus 1 equals 5. So it goes through the point -1, 5, and it has a gradient of -7. So using this point here, I can say when y is 5, 5 equals -7 lots of -1 plus c. So putting the x and y values in there, 5 equals 7 plus c, c equals -2, and that gives me the whole equation now. I know my constant value and I know the gradient. So the answer is y equals -7x minus 2. Write this ratio in its simplest form. A surd question. I just need to write these as surds in their simplest form in order to understand what might be going on here. With a surd question, I'm just going to start by writing out my square numbers up here so that I can use these if I need to in the calculations. Keep on going up like this. Probably won't have to go further than this. So 12 is a multiple of 4, it's the only thing in here. So 12 is 2 root 3. 4 times 3 is 12. 48 can be written, 48 is a multiple of 16. It is a multiple of 4, but we need to spot that it's also a multiple of 16. 48 divided by 16 is 3. I'm going to write these out in full. That is root 4 times 3, root 16 times 3, and now that we're noticing that there's a common factor of root 3 in these, I'll notice that this is 3 times 100, so that's root 100 times 3. That can be rewritten as 2 root 3, 4 root 3, and 10 root 3. Obviously I can divide by root 3 and I get 2, 4, 10. Still not in its simplest form because these are all even numbers, so that's dividing by 2 we get 1, 2 and 5, and that is the simplest form now. Next question, nth term of the linear sequence is 5n minus 3. A new sequence is formed by squaring each term of the linear sequence and adding 1. Prove algebraically that all the terms in the new sequence are multiples of 5. So they're formed, everything in this sequence has follows the algebraic rule 5n minus 3. New sequence is formed by squaring each term of the linear sequence and adding 1. So that is every term equals 5n minus 3 squared, squaring each term and then adding 1. We need to prove that they're all multiples of 5, so I'm going to expand the brackets. That becomes 5n minus 3, 5n minus 3 plus 1. That becomes 25n squared minus 15n minus 15n, doing outsides, insides, plus 9 and then plus 1. So that is 25n squared minus 30n plus 10. And to show that they're all multiples of 5, I need to take the factor of 5 out of the front, so that's 5n squared minus 6n plus 2. Therefore, all terms are multiples of 5. And I've got my statement at the start saying that every term is that, and so that's proving the whole thing at this point. Therefore all terms are multiples of 5. I've shown that these are all terms already. Right, in this question, OABC is a kite. Work out the equation of AC. I've got two coordinates to go on here. I'm just going to mark in straight away on the drawing the sides that I know are equal, because it's a kite. We're told that the diagonals cross at 90 degrees, which is helpful, because We should know that anyway. All kites have diagonals that cross at 90 degrees, but they've specifically shown it here so that you don't need to recall that fact. Work out the equation of AC, that's this line here. So that's not too difficult. I've got the two coordinates here, so I can see that it's a line that has a gradient of change in y over change in x. So I'm going to take the two y values and subtract them. 0 minus 4 over 12 minus 0. Minus 4 over 12, which simplifies to minus 1/3. And it goes through 0, 4, so it has a plus c of 4, y-intercept of 4. So I don't need to do any further calculations. My answer here is y equals minus 1/3 x plus 4. And I'm going to check that works with this point here. Minus 1/3 x, minus 1/3 of 12 is minus 4, plus 4 is 0, and that's what we've got here, 0. So it does work. Work out the coordinates of B next. This is more difficult, but we're going to have to work out the equation of this line here and the crossing point and how far this is away from there. So the first thing I can do is look at this change in here and how long it's taken to get to that point there. This has a gradient that is perpendicular to this one. So gradient of OB is 3 perpendicular to minus 1/3 the line AC, and it passes through origin, so OB is y equals 3x plus 0. Y equals 3x. If I find the coordinates of this by finding where these two lines cross, there may be a quicker way to do this, but at the moment this is what I'm thinking. Find where these two lines cross and then the extension of that line up there. So I'm going to call that point M. M is where, and I set these two lines equal to each other. Y equals 3x equals minus 1/3 x plus 4. And then I'm going to solve this as a simultaneous equation. So 3x equals minus 1/3 x plus 4. I'm going to times everything by 3 to get rid of that 3 there, that denominator. So that's 9x equals minus x plus 12. I should really multiply by 3 there to make sure I don't go wrong with that. And then I'm going to subtract 12. No, I'm not. I'm going to add x to both sides. That's 10x equals 12. Divide by 10. X equals 1.2. Y equals 3x, so y equals 3.6. So M is 1.2, 3.6. Now that if that's gone across 1.2, that is twice the length up here. OB is 2 times OM. So I can just double each of these coordinates now. .4 and 7.2 when I double those two coordinates, and those are my coordinates of B. Quite a complicated question there. We're just approaching that. You just do what you can, find the gradient of the line, look at things in the picture, in the diagram, that are going to help, like the fact that they're perpendicular, like it goes through the origin. You already know the equation of this line, etc. There are probably other ways of doing that. There may be a quicker way that I haven't seen, but you can just approach this from any angle and do what you can. Hopefully you'll get some marks on the way, even if you don't get to the actual coordinates of B. A graph passes through 0, 0. The rate of change of y with respect to x is always 1/2. So it's a constant rate of change. This rate of change of y with respect to x, that's what we find when we find dy by dx. It's another way of saying gradient. Draw the graph of y for values of x from 0 to 4. We know it goes through 0, 0, and it has a gradient of 1/2, so it's going to go through that point there, and finish up. Oh, I only need to go up to 4, so I go up to the point where x equals 4. Next one, a graph passes through 1, 2. The rate of change of y with respect to x is always 0. That's gradient of 0. Draw the graph of y for values of x from 0 to 4. So again, and this is just going to be a straight line here, which I can't do very well on computer. But it's just going through that line. Gradient of 0 means it's horizontal. Y equals 2x cubed plus ax, where a is a constant, so where a is a number value that stays the same. Value of dy by dx when x equals 2 is twice the value of dy by dx when x equals minus 1. Well, I'm going to have to find dy by dx to answer this question, so I'm going to go ahead and do that straight away and then try and set up the equation after that. Dy by dx equals, so 3 times 2, 6x, decrease the power by 1, 2x squared plus, that's 1 times a, and decrease the power by 1 so that it's just a, that stays as a. When x equals 2, that gives us the value 6 times 2 squared plus a, that's 6 times 4 is 24 plus a. When x equals minus 1, we've got 6 lots of minus 1 squared plus a equals, so that's 6 times 1, just 6 plus a. Look at that question again. When x equals 2, the value of that when x equals 2 is twice the value of that when x equals 1. So setting up that equation, 24 plus a is twice the value of when x equals minus 1. So multiplying out that bracket, 24 plus a equals 12 plus 2a. I'm going to subtract a from both sides. That gives us 24 equals 12 plus a. Subtract 12 from both sides, and that gives us 12 equals a. Let's check that that works. 24 plus 12 is 36. 6 plus 12 is 18. 36 is double 18, so that's true, and it works. So a equals 12. Simplify this. This is like a GCSE question, but it's just, we're expected to factorize, so always factorize first with this. Look at the things that are easy to factorize. That one, difference of two squares, need to spot that. So first of all, I'm going to rewrite this bit by bit. I'll use that as my dividing line. That's x plus 5, x minus 5, divided by this is going to stay as x plus 6, and I can factorise the x's there, x minus 5. Up here, I'm not sure what's going to come out of this. I need two things that multiply to minus 12 and add to 4. That's 2 and 6, so plus 6 minus 2. That's good. I've got x plus 6's and x minus 5's. I can't do anything with them at the moment, but once I turn it into a multiplication by flipping the second fraction, because that's how we deal with fractions when we're dividing, times by x over x minus 5, flip that second fraction, x plus 6. I can now cancel those and cancel these as well. Cancel the x minus 5s, cancel the x plus 6. That leaves me with x times by x minus 2, x times by x minus 2 over x plus 5 times by 1. Having cancelled that, x plus 5 times by 1. And that's as simple as it's going to get. I can see nothing else in there is factorising. So x minus 2 over x plus 5. That's the answer to that. It's always about factorising these. So we're told x to the power of 3 over 2 equals 8, where x equals 0, and y to the power of minus 2 equals 25 over 4, where y is greater than 0. Work out the value of x over y. So I need to rewrite both of these expressions. X to the power of 3 over 2 equals 8. So first of all, I'm going to cube root this. So that's going to be x to the power of a half. So that's my first thing, is cube rooting. Cube root of 8 is 2. X to the power of a half equals 2, so I'm going to square both sides to get x on its own. X equals 2 squared is 4. Y to the power of minus 2 equals 25 over 4. So to get rid of the minus sign, I'm going to flip the fraction. Y squared equals 4 over 25. Square root both sides gives me y equals 2 over 5, square root top and bottom there. Square root 2 is 2 over 5. X over y is 4 divided by 2/5, which is the same as 4 times by 5 over 2. Flip that second fraction again. That always works. We can always do that. Flip the second one and times the numerators together there. So that equals 20 over 2, which equals 10. XYZ is a right angled triangle. Use triangle XYZ to show that sine 60 equals root 3 over 2. Sine 60, not sine 30, so I need to first of all show 180 minus 90 minus 30 equals 60, so I label that 60 degrees. I'll label these hypotenuse, adjacent to that angle there, and opposite. Sine 60 equals, sine is so, opposite over hypotenuse. Haven't got the opposite, so I'm going to use Pythagoras to get that, because it's a right angle triangle. So Pythagoras equals, not equals, Pythagoras. YZ squared equals 2 squared minus 1 squared equals 3. 4 minus 1 is 3. So YZ equals root 3. Sine 60 is opposite over hypotenuse, so that's YZ over XZ. Sine 60 equals YZ is root 3 over hypotenuse 2. triangle ABC has an obtuse angle at C. That's greater than 180. Sorry, greater than 90, less than 180. Given that sine A equals 1/4, use triangle ABC to show that angle B is 60 degrees. So we haven't got calculators, it's a non-calculator paper, so it's going to be using the trig ratios that we know already. We can look at, maybe we've got angle B we're looking at, and seeing as we've just up here found that sine 60 equals √3/2, that's going to be part of our answer. It's the same question, 15b, so we can use that answer later on. So in this, sine A equals 1/4, so we're given information about that. What we can use here is the sine rule. So sine A over the opposite side, 2 minus √3, equals sine B over 4√3 minus 6. Sine A is 1/4, so 1/4 over 2 minus √3 equals sine B over 4√3 minus 6. Now, I'm not sure where this is going yet. I'm just doing what I can to try and solve this. Sine B, if we get sine B equaling that, sine B equaling that, then we know that B itself is 60 degrees. So that's what I'm hoping for when I multiply these out, but I'm not sure if it's going to happen. So 4√3 minus 6, if I multiply this side by that, so 1/4 of 4√3 minus 6 over 2 minus √3 equals sine B. Simplify that, that is √3 minus 6 over 4, that's minus 3/2 over 2 minus √3 equals sine B. There may be an easier way to do this with algebra, but I can't see it at the moment, so I'm just going to keep on going with this method. I now need to rationalize the denominator in that one. So √3 minus 3/2, rationalizing the denominator, I need to multiply by the plus version of that, so that's times by 2 plus √3 over 2 plus √3, so multiplying by 1 in the form 2 plus √3 over 2 plus √3. That's going to give me, on the top, uh, 2√3 minus 3/2 times 2 is minus 3, plus 2 minus 3/2 times by √3. Well, as I say, plus 3√3, so that's plus 3 minus 3/2 √3, all over 2 times 2 is 4, plus 2√3 minus 2√3. They cancel out, that's why we did them in the first place, minus 3. So that equals minus 3 plus 3, they cancel out, 2√3 minus 1.5 √3, 3/2 √3 over 1 equals 2√3 minus 1.5 √3. That is half √3, which is √3/2. 2 minus 1.5 is a half, so it equals √3/2 equals sine B. √3/2 equals sine B equals sine 60, therefore B equals 60 degrees. Just looking at that and the mess I've made, I'm pretty sure there's a quicker way to get there, but that is my answer. And it does follow, and it does go through. This one, trig identities, I'm just going to write down the two trig identities that we know for this exam. So that's tan theta equals sine theta over cos theta, and sine squared theta plus cos squared theta equals 1. Just check whether these are given in the formula sheet or not. Yes, they are. So we've got these to work with. Also, the sine rule was given in the formula sheet, so we could have used that for the previous question. So going back to this question, I can see in here there's no squaring going on. There's nothing squared, so I'm going to try and use this throughout. So tan theta, rewrite it as sine theta over cos theta. One over tan theta. That's the inverse of this one. So I've put it 1 over, so that's cos theta over sine theta. If I want to add those together, I need to have common denominators. So common denominators, I need to multiply both by cos theta and by sine theta. So that's going to give me, first of all, by cos theta, that is well, I need to multiply this one by sine theta, so that's going to be sine squared theta. Let's put what I'm doing down the side. Times by sine theta over sine theta, that side. Sine squared theta over sine theta cos theta. Plus this one I'm going to times by cos theta over cos theta. This is to get the same denominator without changing the value of the fractions. That gives me cos squared theta in the numerator over sine theta cos theta in the denominator. So that equals sine squared theta plus cos squared theta over the same denominator, sine theta cos theta. But that sine squared theta plus cos squared theta equals 1. So the numerator is 1 over sine theta cos theta, and at that point I've finished the question because I've reached this conclusion here. Put some equal sign in all the way down there. And that's the end of the test.